Hello, welcome back once again. Today we have another interesting indefinite integral from the MIT Integration Bee 2025. We have to evaluate the integral of 4 raised to the power of x whole divided by 3 into bracket 2 raised to the power of 2x plus 2 minus 2 to the power of x in the bracket close, right? Then minus 4 into bracket 2 raised to the power of 2x plus 1 and then plus 1 bracket close and then dx, right? So let's see how we're going to tackle this problem. Now before we proceed, remember our integral is equal to this I. Then let us take note of the following laws of indices. So we know that a raised to the power of m plus n is same as a raised to the power of m multiplied by a raised to the power of n. And again, a raised to the power of m times n is same as a raised to the power of m in brackets and then raised to the power of n. So we're going to make use of these laws of indices right over here and also right over here. So our I is going to be equal to the integral of 4 raised to the power of x, then divided by, so here we have 3 into brackets, so this is going to be 2 raised to the power of 2x multiplied by 2 raised to the power of 2 according to the law of indices, then minus 2 raised to the power of x bracket close, and here negative 4 into brackets, so this one right over here is going to be 2 raised to the power of 2x multiplied by 2 raised to the power of 1 and then plus 1. And then we have our dx. Okay, so from here now, our I is going to be equal to the integral. So here, 4 raised to the power of x, remember the base is 2 squared, so we have 2 raised to the power of 2, and then raised to the power of x. Then divided by, so here we have 3 into brackets, so 2 raised to the power of 2x multiplied by 2 squared, that will give us 4. And then minus 2 raised to the power of x. Here minus 4 into brackets, 2 raised to the power of 2x multiplied by 2 raised to the power of 1, that is 2, and then plus 1. And here we have our dx. Now, let us make use of these laws of indices. I is going to be equal to the integral, so up there is same as 2 raised to the power of x, and then squared. Then divided by, here, 3 into brackets, this is same as 2 raised to the power of x whole squared multiplied by 4 minus 2 raised to the power of x. And here minus 4 into brackets. This is same as 2 raised to the power of x whole squared multiplied by 2 and then plus 1. And here we have our dx. Now time to make substitution. So we're going to let 2 raised to the power of x equals t. Now take the ln of both sides, we get x multiplied by the ln of 2 is equal to the ln of t. Divide both sides by the ln of 2, we get x is equal to the ln of t divided by the ln of 2. Now we need to take the derivative on both sides, right? So we're going to have here dx is equal to the derivative of ln of t with respect to t will give us 1 over t. And with the denominator there, we get 1 all over t times the ln of 2 and then the t. So we're going to make the necessary substitution into the original integral. So here our I is going to be equal to the integral of, now 2 raised to the power of x squared will become t squared, right? And then divided by, so this is going to be 3 into bracket 4 times 2 raised to the power of x squared will be 4t squared minus 2 raised to the power of x, which is t, right? And then minus 4 into bracket 2 times 2 raised to the power of x squared will become 2t squared and then plus 1. And do not forget our dx is equal to the t divided by t multiplied by the ln of 2. Now, I think we have some nice cancellation, right? So here, this t is going to bring this one down to just t. Then our ln of 2 is going outside, so we have 1 all over the ln of 2 multiplied by the integral of, so here we have just t. And then opening the bracket, we get 12t squared minus 3t, right? And here minus 8t squared. And here, oh, that is minus 4, right? So that is minus 4. So sorry for that. So here we have minus 8t squared and here minus 4. and we have our dt. Now we're going to simplify where necessary, right? So our I is going to be equal to 1 all over the ln of 2 multiplied by the integral of t, then divided by, so we have 12t squared minus 8t squared will give us 4t squared minus 3t, and then minus 4, and here we have our dt. Okay, here comes the magic. We're going to do something really cool here. Now, let's think about the derivative of this denominator right over here. Its derivative is equal to 8t minus 3. Now, let's do the following. If there's 8 here, we're going to have 1 over 8, which is simply 1 over 8 times the ln of 2. If we have a negative 3, then we need to put a positive 3, right? So nothing changed, still remain our original integral, right? Okay, now I'm going to show you guys the reason for this trick. Okay, so this is going to be equal to splitting the denominator time. So this is going to be the integral of, so here we have 8t minus 3 divided by 4t squared minus 3t minus 4, and then the t, and then plus 1 all over 8 ln of 2 multiplied by the integral of, so here we have 3, right, divided by 4t squared minus 3t minus 4, and then the t. Now let us recall the standard integral formula. A really cool one. So we know that the integral of f prime of x divided by the function of x itself, right, that this is equal to the ln of the function itself. So it's going to help us here, right? Because this numerator is the derivative of the denominator. So our I is going to be equal to 1 all over 8 times the ln of 2. So this is going to be the ln of 4t squared minus 3t and then minus 4. And here plus 1 all over 8 ln of 2, right? Multiplied by the integral of, so we need to write this 3 outside, right? So this 3 all over 8 ln of 2, then we have 1 all over, so this is going to be 4t squared minus 3t minus 4, and we have our dt. So what is our next step? So let's solve this part. So let's call this a sub 1. So our a sub 1 is going to be equal to, so how are we going to manipulate that? Now, let us do the following. We know that a minus b whole squared is equal to a squared minus 2ab plus b squared, right? So now, we have 4t squared, right? And we have minus 3t and we have minus 4. This will be same as, first let's start with something squared. 4t squared is 2t whole squared. Now remember that we're going to have a minus 2 times that 2t. But how do we make that place to be 3, as we can see here? So we only do the following, that is multiplying by 3 all over 4. We know that 2 times 2t is 4t, but 4 cancel 4, we get 3t, right? Okay. Now here we're going to have the square of this 3 all over 4, which is 9 all over 16. But we have a negative 4 here. So 9 over 16 minus what will give you negative 4. So it's going to be 9 over 16 minus 73 all over 16. So you can see. Now from here, we're going to see that 4t squared minus 3t minus 4 is equal to, so that will give us 2t minus 3 all over 4, right? Minus 3 all over 4 whole squared. And do not forget we have a negative 73 all over 16. That's cool, right? So our a sub 1 is going to be equal to 3 all over 8 times the ln of 2 multiplied by the integral of, here we have 1 all over So this one here is going to be 2t minus 3 over 4 whole squared minus 73 over 16, and then we have our t. Substitution time again, right? So we're going to do the following. We're going to let 2t minus 3 over 4 equals, let's say, y, right? So for x, we see that, so for t, so we see that t is going to be y over 2 plus 3 over 8. Hope I'm making sense. Oh, is that how to solve for t? Yes. Okay, so it's going to be y all over 2 plus 3 all over 8. Okay, so differentiate both sides, so we get dt is equal to 1 over 2, right, dy. So our a sub 1 is going to be equal to, so remember we have 3 all over 8 ln of 2, right, 3 all over 8 ln of 2 times the integral of 1 all over, so this is going to be y squared, right, and then minus 73 over 16 multiply the t, which is 1 over 2 dy. Taking the 1 all over 2 outside, and we get the following: a sub 1 is equal to 3 all over, this is going to be 16 ln of 2 times the integral of 1 all over, so we can write this as y squared minus, to do this a perfect square, we get square root of 73 divided by 4 whole squared, and then we have our dy. Now we need to recall the following. We know that from the standard integral formula that the integral of 1 over x squared minus a squared dx is equal to 1 over 2a times the ln of x minus a divided by x plus a, and then plus c. So use that here, we get the following: 3 over 16 ln of 2. Oh, that is not going to be enough, right? So that is not going to be enough. So we're going to have a sub 1 is equal to, this is 3 over 16 ln of 2 times, this is going to be 1 all over, remember our a squared is square root of 73 over 4, so this is going to be 2 multiplied by square root of 73 over 4, right? Then multiply with the ln of, so this is going to be y, right? Y minus square root of 73 over 4 here, and then divided by y plus square root of 73 over 4, and then plus c. So simplifying properly, you're going to have a sub 1 is equal to, so to square the hand here, we get just 3 all over. So that is going to be 3 all over 8 square root of 73 ln of 2, right? So 3 all over 8 square root of 73 ln of 2. So that is what we have next. So multiply by the ln of, multiply the numerator and the denominator by 4, we get 4y minus square root of 73 divided by 4y plus square root of 73. And here we have our plus c. Now put everything together, we have the following. Our I is equal to, so that is 1 over 8 ln of 2 multiplied by the ln of 4t squared minus 3t minus 4, right? And here plus 3 over 8 square root of 73 ln of 2, then multiply the ln of 4y minus square root of 73 divided by 4y plus square root of 73, and then plus c. So from here, we're going to make our necessary substitutions, right? So we know very well that our y is equal to, don't forget that y is equal to 2t minus 3 all over 4, right? And we see that 4y is going to be, to multiply this by 4, giving us 8t minus 3. So our I is going to be equal to, 1 over 8 ln of 2 multiplied by the ln of 4t squared minus 3t minus 4, right? And here, this is going to be plus 3 all over 8 multiplied by the square root of 73 multiplied by the ln of 2 times the ln of, so we have here 8t minus 3 minus square root of 73 divided by 8t minus 3 plus square root of 73 and plus c. Now finally, there is one more substitution remaining, that our t is equal to 2 to the power of x. So this implies that 4t is going to be equal to 2 raised to the power of 2x, 4t squared, I mean, because t squared from here, t squared is equal to 2 raised to the power of 2x. So 4t squared will be 2 raised to the power of 2x plus 2, and 8t will simply be 2 raised to the power of x plus 3. So we substitute all these things into this, our final answer. And let's see the outcome. So we're going to have the following, that finally our I is going to be equal to 1 over 8 ln of 2 times the ln of, so we're going to have here 2 raised to the power of 2x plus 2, right? Minus 3t is going to be 3 into bracket 2 raised to the power of x, and then minus 4, right? And plus, so this is going to be equal to 3 into bracket 3 all over, I mean. So this is 8 square root of 73 times the ln of 2. So here times the ln of, so what do we have here? So let me complete it here. So we have 2 raised to the power of x plus 3 minus 3 minus square root of 73, and then divided by 2 raised to the power of x plus 3 minus 3 plus square root of 73. And then we have our plus c. So this right over here is our solution. Please, if you really enjoyed the video, kindly subscribe to this channel. Support the channel by subscribing. Also like, comment, and share.